Right. Am I audible? Okay. Then you can go ahead. Thank you. Right. The කට්ටිය අඩුයි වගේ තියෙන ටික. නෑ අපි ටිකක් හරි කරමු අද. ඔයාලා ඇවිල්ලානේ ඉන්නේ. Right. So today lesson is fundamentals of sequence and series. Right. What is mean by a sequence? අද තියෙන්නේ අපිට fundamentals of sequence and series. So what is mean by a sequence? We normally say the sequence is a infinite list of numbers. So infinite list of numbers කියන්නේ මොකද්ද? Infinite කියන්නේ අපිට ගණන් කරලා ඉවර කරන්න බැරි. තරමට ඒ කියන්නේ list of numbers තියෙනවා. එතකොට ඒවට අපි කියනවා sequence එක කියන්නේ sequence can be within a range and also it can be infinite list of numbers. Right? But the function of the sequence is as the set of, normally the function of sequence, you can describe the sequence as a function. Its domain is a set of positive integers. Right? Each element of the sequence we call a term. For example, if you consider the first sequence 0, -5, -10, -15, and -20, each number 0 is one 0, -5, -10. Each one we call a term. Right? So if we consider the first series, this one, the first number or the 0 is representing which term? First term of that series. -5 is representing the second term of the series. Right? Likewise, you can see -10 is the third term, -15 is the 15th term, sorry, fourth term, -20 is the fifth term. Likewise, you can say for each element, you can call it a sequence. We have my element එකකටම you can ඔයා අපිට කියන්න පුළුවන් term එකක්. sequence එකක තියෙන හැම element එකකටම අපි කියනවා term එකක් කියලා. එතකොට පළවෙනි element එකට නැත්නම් මුලින්ම display වෙන number එකට the sequence එක starting number of the sequence we say the first term. Right? The sequence එක start කරන number එකට අපි කියනවා first term of the series. Right? So ඒ වගේ අපිට මේ sequence එකක් කියවුවාම අපි jump pieces තැනක ඉඳලා තවත් තැනකට ලියන number range එකක්. අපි සීක්වන්ස් එක. ඒතකොට සීක්වන්ස් එකේදී ෆස්ට් නම්බර් එකට අපි කියනවා ෆස්ට් ටර්ම්. සෙකන්ඩ් එකට කියනවා අපි සෙකන්ඩ් ටර්ම්. තර්ඩ් නම්බර් එකට අපි කියනවා තර්ඩ් ටර්ම්. likewise. right? So අපිට මේ සීක්වන්ස් එක ෆන්ක්ෂන් එකක් විදිහට ඩිස්ප්ලේ කරන්න පුළුවන්. Here if you look at the sequence which is described with the F notations, if you use F, if you describe this as a function, you can display it as a fx, right? So if when x is 1, you can write f1. The value of the function when the x is 1 is equivalent to a1, right? So if you describe the sequence as a function, the first value of when you substitute or when you consider the first value, we can represent it as a1. We normally represent term using the a, right? If it is a1, that means it is the first term. If it is a2, that means it is the second term. If it is a3, that means it is the third term. Likewise, you can write all the term with this symbol, right? So generally we write down we can write down the general term within a given series, right? You can denote the sequence by, if you got this one, this is a1. This is a2. Term is representing by a. So first term is a1. Second term is a2. Third term is a3. Fourth term is a4. Likewise, nth term is, what is then nth term? N many term you can represent as n, right? So if you don't know the exact number, you can represent the term. කීවෙනි term එකද කියන එක අපි හරියටම දන්නේ නැත්නම් we can represent it as a general term. The general term we normally represent by as nth term or else like a in, right? අපි sequence එකක තියෙන හැම term එකකම a වලින් තමයි represent. ඒතකොට first term නම් අපි a1, second term නම් a2, third term නම් a3 ඒ වගේ define කරගෙන. ඒකට අපි මොනවා හරි term එක අපි term එකේ number එක දාන්න නැත්නම් අපි general term එක we represent it using a in. This is we call nth term. Right? This is nth term. So what is the fifth term of series 2? You consider this series. What is the fifth term of this series? What is the fifth term of the second series? So what is the fifth term? First term is 1, second 2, third 3, fourth 5, fifth term, or else a5 is equivalent to 7. Right? If you consider the third one, what is the third term of the third sequence? So what is the third term of this sequence? It is 1 over 2 to the power 3. Right? So how do we define the general term of this series? The third series, for the third series, the nth term you can define as 1 over 2 to the power n. If you substitute 1, or if you want to find the first term, if you know the general term, then you can easily find each term of the series. අපිට මේ general term එක ගැන idea එකක් ගන්න එකේ ප්‍රයෝජනේ තමයි නැත්නම් වාසිය තමයි අපි, if you know the general term, you can write down each term based on our general term. So you can write the third sequence as the general term of third sequence as n equal 1 over 2 to the power n. If n is equivalent to 1, then that means first term of this series, it become 1 over 2 to the power 1, or else 1 over 2. Right? If n is equivalent to 2, that means the second term, it is equal to 1 over 2 to the power 2. Right? If it is third term, 1 over 2 to the power 3. Fourth, 1 over 2 to the power 4. If it is sixth term, you can write it 1 over 2 to the power 6. Right? If you know the general term or the nth term, you can easily find each term or terms in your sequence. Right? Oh, Rohit, I think Rohit sometimes some student may doesn't know this, yeah? But I couldn't send the message, but I have told you in the last class there will be class today. නේද මම ඔයාලට මට මතක හැටියට කිව්වා last class එකේදී.
මේ රසික සරුවත් කිව්වද ක්ලාස් එකක් දානවා කියලා. ඊට පස්සේ අර මොන ක්ලාස් එකේ තියෙන එක ෂුවර් නැති හින්දා මම ගෲප් එකේ මැසේජ් එකක් දැම්මා අද ක්ලාස් තියෙනවද කියලා අහන්න. ඊට පස්සේ රිප්ලයි කරේ නැහැ කවුරුත්. ඒක හින්දා අද ක්ලාස් නැහැ කියලා හිතුවත් දන්නේ නැහැ.
එහෙම කියලා හිතුවක් දන්නේ නැහනේ. කමන්නේ අපි දැන් පටන් ගත්තා හන්ද අපි පැයක් විතර කරලා නවත්තමු. අනිත් අයට පාඩුවක් වෙනවනේ එහෙම වුණොත් නැත්තම් නේද? අපි පැයක් වගේ කරමු එහෙමනම්. ඔව් මටත් මම ඒක රසිකසට ගොඩ දවසකට කලින් කිව්වා මටත් ඒක මේ ලාස්ට් වීක් එකේ මේ අතක් ගන්න බැරි වුණා. මම රසිකස කරන්න හිටියක් දන්නේ නැහැ නේද බලමු අපි. මට ඒක ඔව් ගෲප් එකට දාන්න බැරි වුණා ඒක ඇත්තටම. අපි 1 hour වගේ කරමු නැත්තම් රාදිනේ ඔයාලත් ඇවිල්ලා ඉන්නකොට. right දරුවා අපි ටිකක් කරමු. අපි 8 විතර වෙනකන් කරලා නවත්තමු. එතකොට අනිත් අයට ලොකු change එකක් වෙන්නේ නැහැ. Right. අපි දැන් මේ sequence and series බැලුවොත් එහෙම අපි if we know the nth term then we can easily write down each term or from starting from 1 to n you can write down each term of the sequence. Right. Here it is, write down if you got this example. Write down the first 3 terms of the sequence in which general term is an equal n squared. Then general term එක දීලා තියෙනවා. How do we find the first 3 terms? How do we find the first 3 terms? Right? How do you find the first 3 terms? When n equal 1, first term is 1 squared. When n equal 2, it gives the second term. Second term is 2 squared. N equal 3, it gives the third term, then 3 squared. Then what are the first 3 terms? 1, 4, and 9. And also it asks you to write the general term of the sequence 1, 3, 6, 10, 15, 21. How do you find the general term? You have to find out how the sequence is written down and then check how to write the general. අපි පොඩි sequence එක බලලා අපිට බලා ගන්න පුළුවන් ඒ කියන්නේ we can write down the general term. If you look at this, the first term is equivalent to 1. Second term is equivalent to 3. Right? අපි normally general term එක ලියනකොට we have to consider the nth term. අපි the කීවෙනි term එකද first term එකද second term එකද කියන එක consider කරලා ඕනේ. We have to write down the general term. Right? So A2 is 3, A3 is equivalent to 6. Right? So you can write this as 2 plus 1 or else 3 plus 3. But when you write like this, you can't write down this term. Or else you can write it as 1. So if you got this, you can write down this as, අපිට මේක 2 plus 1 divided by 2. This part you can write 3 plus 1 divided by 2. If you got A4 also you can write. A4 is 10. 10 you can write 4 into 4 plus 1 divided by 2. Therefore, you can write the general term as En is equal n into n plus 1 divided by 2, right? So, this is the general term. We can write down the general term like this. අපි general term එක ඒ වගේ ලියන්න පුළුවන්. Right? Right. අපිට දැන් මේම terms තියෙද්දි if the succeeding term is larger than the preceding terms. Succeeding terms mean the term, if you consider this term, if this is the succeeding term, you can consider this as the preceding term or as the fifth as the, you consider this one, succeeding term is 15 for the 10. Preceding term is 5 for the 10, right? Or if you consider 15, then the preceding term is 10, right? Succeeding term කියන්නේ පස්සේ තියෙන term එක, preceding term කියන්නේ කලින් තියෙන එක, right? So if the succeeding term is larger than the preceding term, we call the sequence is increasing sequence. අපිට පස්සුව තියෙන term එක කලින් තියෙන term එකට වඩා වැඩි නම්, ප්‍රමාණයෙන් විශාල නම්, we say it is increasing sequence. මේකට කියනවා increasing sequence එකක් කියලා. Okay? So if an is less than an plus 1, then we call it increasing sequence. Okay? If you consider this series, ගන්න පේනවා ඇති succeed, if you consider this one as succeeding sequence, then half is the preceding. What is the larger one? 1 over half the large one, 1 over 4 the. 1 over 2 the larger one, 1 over 4 the half or quarter. You know, half is larger than the quarter. Therefore, the succeeding term is less than the preceding terms. Therefore, we say this is decreasing sequence. Succeeding term එක preceding term එකට වඩා less than වෙනවා. We say it is decreasing sequence. So that means if an is greater than an plus 1, we call it as decreasing sequence. If an is less than an plus 1, we call it is increasing sequence. Right? And now, අපි දැන් දන්නවා term එකක් කියන්නේ මොකක්ද? And the sequence එකක් කියන්නේ මොකක්ද? Sequence එකේ each element we call term. So now we look at how do we represent a series. Here it says if AK is a sequence, then series you can denote by sigma k equal 1 to any value AK. The series is the sum of the sequence. අපි sequence එක sum එක ගන්නවා. හිතන්නකෝ 1 to 5 තියෙන terms වල sum එක සලකනවා. Then we have to write down a1 plus a2 plus a3 plus a4 plus a5. Right? The sum of these 5 terms we can write as sigma k equal 1 to 5 ak. සිග්මා වලින් අපි represent කරන්නේ sum එකක් කියන එක. මේ දෙකේ එකතුව we can generally write as we write using or we can denote using sigma. Sigma k equal 1 to 5 if you consider these 5 terms, right? Sigma ak starting from k equal 1, right? We denote it as Sn, sum of n terms. We represent using Sn. So here you can see where the Sn is equivalent to a1 plus a2 plus a3 plus up to the n value. Right? Here it says the AK is represent the terms of the series and the Sn we call it partial sum. Why we say it's partial sum? Partial sum කියලා අපි කියන්නේ අපි කොටසක් sum එකක් තමයි හොයන්නේ. So therefore we say Sn is the partial sum of the series. Right? Here we are going to find out the sum of some part of our sequence. Right? So if the sequence is, we say that sequence can include an infinite number of terms. Right? So if you are considering part of that, we can say the partial sum of the series you can denote by Sn. Right? So Sn කියන එක තමයි sigma notation එක දාලා යන්න පුළුවන්. නැත්තම් අපි sigma notation දාලා Sn දාලා හරි අපිට පුළුවන්. the normal මේ sigma එකෙන් තමයි අපි සාමාන්‍යයෙන් sum එකක් කියන එක represent කරන්නේ. We call it a summation notation or the sigma notation. Okay? So if you consider Sn, we normally write is the first term of the sequence, first n terms. Sn can first n terms of the sequence. You can write as අපි n terms ගන්න here is 5 කියන එක තමයි we represent using a1, a2, a3, a4, a5. If it is n term, then a1 to n term you have to consider. Then you can represent it as Sn equal I equal 1 to n. Sigma represent කරනවා නම් sorry, sigma use කරනවා නම් to represent this, represent the summation. අපි sigma ලියලා ඉවරලා මේ පහළ දානවා. අපි කොතනින්ද start කරන්නේ. Here you can see I equivalent equals 1. කොතන ඉඳන් කොතෙන්ටද කියන එක තමයි sigma එකේ පහළිනුයි උඩිනුයි දාන්නේ. පහළින් දාන්නේ අපි start කරන්නේ කොතන ඉඳන්ද? ඉහළින් දාන්නේ sigma ගේ end කරන්නේ කොතනින්ද? Where do we stop representing the on the sigma, right? So in the upper part we represent the end point. Then in the lower part we represent the starting point we consider it for the summation, right? So this is the terms or the number of terms or the general term we are writing. You can write down the general term or else the term which is the term that we represent. Here we have used I. We are using. You can write I as I equal 1 to n. Right? We do not put here. Normally අපි මෙතන n කියලා දාන්නේ n වෙනුවට අපි different symbol එකක් පාවිච්චි කරලා ඒක පටන් ගන්නෙ කොතන ඉඳන් හොදද. Normally SN වලින් represent කරන්නේ මුල term ටිකේ එකතුව. right? මුලින් තියෙන terms ටිකේ එකතුව. එතකොට මුලින් තියෙන terms එක එතකොට first එකෙන් පටන් ගන්න කොතෙන්ට යනකම් එකතුවද කියන එක තමයි SN වලින් represent කරන්නේ. Here says the letter I is in the above called the index of summation. Okay? So if you put I in the below of the sigma, you don't need to put in upper part of the sigma also, right? අපි මෙතන I පහලින් දැම්මම අපිට උඩින් ලියන්න ඕනේ I equal 1 to I equal n කියලා. Instead of that, we write I equal 1 in the below and n in the above the sigma. Right? Right. Here you can pay if you consider this example, here it say sigma I equal 1 to 4 I square. That means I කියන්නේ සමානයි 1 ඉඳන් 4 දක්වා. You have to get the summation of this. I square. So I equal to 1 square plus 2 square plus 3 square. Instead of 5, you can put the number from 1 to 4. Right? 1, 2, 3, 4. Then get the summation. You can get 30 from that. Right? You consider this one. Here instead of I, you can use J or whatever. Right? Here you use I. Sigma J equal 2 to 4, J plus 1, 2J divided by J plus 1. Here you can see the starting value is considered as 2. Right? So instead of 1, you can put 2 into J. Then 2 into 2 divided by 2 plus 1 when J equal 2. When J equal 3, 2 into 3 divided by 3 plus 1. When J equal 4, 2 into 4 divided by 4 plus 1. Right? ඔයාලා J කියන එක දෙකේ ඉඳන් 4 වෙනකන් දක්වා විතරයි මේක හොයන්න කියන්නේ sum එක. දෙකේ ඉඳන් 4 දක්වා 2J divided by J plus 1 කියන එක දාලා තමයි අපි හොයන්න. එතකොට අපි J වෙනුවට මොලේ දෙක දානවා. එතකොට දෙක දැම්මම මෙතන කියන්නේ 2J කියන එකේ අදහස තමයි 2 should multiply by J. So instead of J, if you put 2, then 2 into 2 divided by 2 plus 1. Then you can increase J by 1. 2 plus 1 is 3. And then 3 plus 1, 2 into 3. Then when J become 4, 2 into 4 divided by 4 plus 1. And see 4. This part generate 4 divided by 3. This is 2 into 3 is 6. 6 divided by 4. 2 into 4 is 8. 8 divided by 5 is the answer for this one. Now you get what you get now. දැන් අපි හමුනේ භාග value ටික. Right? The fraction which is no, the denominators are not equal. When denominators are not equal, we what you should do when you adding them, you have to find the common, least common multiple of denominators, right? The value of the denominator. Least common multiple is 30. You can write 4 divided by 3 as 40 divided by 30. 3 divided by 2 as 45 divided by 30. 8 divided by 5 as 48 divided by 30. Right? Then if you add these three together, can get 133 divided by 30. You can write it as 4 into 13 divided by 30. Right? So if you then if you consider this example, you consider the third one. In the third one also, now it shows මෙතන පේන වෙද්දි sigma එකේ. What is this? What is represented by the value above the sigma? Sigma එකට ඉහළින් තියෙන value එකේ මොකක්ද represent කරන්නේ? It is representing the infinity. Infinity marks in you. We can't say exact value, but starting from 1, you can මෙතනින් කියවෙන්නේ එකේ ඉඳලා infinity දක්වා, or the අනන්තය, normally if we call it in Sinhala, it is අනන්තය. If we සිට අනන්තය දක්වා 1 over I කියන එක තමයි මෙතනින් represent කරන්නේ. එතකොට ඔයගොල්ලන්ට sum එක ගන්න වෙනවා එකේ සිට අනන්තයක් දක්වා value. Right? මුලින්ම I වෙනුවට 1 දානවා, ඊළඟට 2 3 4 5 6. මේ n වාරයක් value තියෙන terms වල, අනන්ත වාරයක් තියෙන terms වල එකතුව තමයි sigma I equal 1 to infinity 1 over I වලින් represent කරන්නේ. So if it is 1 over I sigma 1, so sigma I equal 1 to infinity 1 over I means you have to get the summation of the value of infinity number of terms, right? Sum of infinity number of terms represented by this part. Right. Now we look at arithmetic and geometric progression. First, we will look at the arithmetic progression. So, arithmetic progression is a sequence of numbers which has if you consider two successive terms, the difference between two successive terms are same. Right? If you consider any two successive terms, the difference between those if the difference between those terms are equivalent within the sequence of numbers, any two successive terms, if you consider any two successive terms, if the difference between those two terms are equivalent, we call it is arithmetic progression. Right? So අපි arithmetic progression එකක් කියන්නේ අපි sequence එකක් ගත්තාම ඒකේ ඕනම තැනක එක ළඟ තියෙන term දෙකක් ගත්තොත් ඒ term දෙක අතර වෙනස same නම් වෙනස සමාන නම් ඕනම term එක ළඟ තියෙන term දෙක සෑගුවොත් ඒ හැම term දෙකක් අතරම තියෙන වෙනස සමාන නම් we call it as arithmetic progression. Arithmetic progression has a common difference. If you have common difference between two successive terms, then we call it as arithmetic progression. Normally, we represent the common difference by D. Right? We D වලින් තමයි represent කරන්නේ. So, if you consider the example 1, you can see that if you consider 2 and 5, what is the difference between 2 and 5? It is 3. If you consider 5 and 8, again the difference between these two is 3. If you consider 8 and 11, the difference is same. Therefore, we can say this is arithmetic progression with the common difference D equivalent to 3. Right? So, if you consider the second example, in the second example, it shows the first term is 15, second term is 10. How do we find the common difference? අපි successive value එකෙන් තමයි preceding value එක අඩු කරන්නේ. So ඉස්සරහම තියෙන එකෙන් තමයි 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. You consider the second series, 10 minus 15 is minus 5. Just say 5 minus 10 is minus 5. 0 minus 5 is minus 5. Minus 5 minus 0 is minus 5. Right? So the common difference between these two successive terms, if you consider any two successive terms, then the difference is minus 5. Therefore, the common difference of those terms are equivalent to minus 5. Right. අපිට එහෙම common difference එකක් තියෙනවා නම් we can write a formula for the nth term. අපි දන්නවා නම් common difference එක you can easily write down the formula for the nth term. Here you can see. If you remember the equation, if you know the right, before that, consider the arithmetic progression 3, 6, 9, 12, and 15. Here you can see 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3. Therefore, the common difference is equivalent to 3. The first term is equivalent to A1, or first term you can write down as A1, it is equal to 3. Second term is 6, which is equivalent to 3 plus 2 minus 1 into 3. Third term is equivalent to 3 plus 3 minus 1 into 3. Fourth term is equivalent to 3 plus 4 minus 1 into 3. එතකොට මොකක්ද අපිට මේකෙන් එන්නේ? You can write any term like the general term of any C equals as 3 is equivalent to A1. Instead of 3, you can put A1 plus the number with this one is representing the term number. Can see the term number. Therefore, instead of this 2, 3, 4, you can put n. Right? N minus 1. This is the common difference. Right? Therefore, any arithmetic progression you can represent by A1 plus n minus 1 into D. If it is arithmetic progression, you can write as a n term of that arithmetic progression as a n equivalent A1 plus n minus 1 into D. Right? එතකොට අපි දන්න arithmetic progression එකක් නම් අපිට ඒකේ nth term එක ඕනම term එකක් නේද? Right? The common term, right? Or the general term, you can write as an, general term we denote as an, equivalent A1 plus n minus 1 into D. A1 is the first term of the sequence. D is the common difference. N is the nth term, right? Or else the common term. Sorry, we normally say the general term, right? So, general term of any arithmetic progression, you can write as n equal A1 plus n minus 1 into D. Right. How do you find the 12th term of arithmetic progression? It said the first term is 12, common difference is minus 3. How do you find it? Ask you to find 12th term. You know the first term. First term is 12. N is now 12. 12 minus 1 is 11. The common difference is minus 3. Then 12 plus, no, you can write, okay, minus 33. Minus 33, 12 means minus 21. Okay? Likewise, you can find the 12th term of this arithmetic progression. The second one, find the first 4 terms of the arithmetic progression in which the first term is 8 and the common difference is 4. The first term is 8, then ask you to find first 4 terms. If the common difference is 4, then you don't need to get this, substitute the values into the equation. You just write add 4 into 8. Therefore, the second term is 12. Add 4 into 12, third term is 16. Add 4 into 16, fourth term is 20. එතන කියන්නේ first 4 terms හොයන්න කියලා. Third one, find the first 3 terms of arithmetic progression in which 10th term is 10 and common difference is 2. Now you know the 10th term. 10th term is 1 to 10. Instead of 10, you can put 10. You don't know E1. N minus 1 is 9. 10 minus 1, 9. Common difference is 2. Then A1 is equal to 10 minus 18. That is minus 8. Right? You can see the answer for this one is A1 is minus 8. They ask you to find the, if you know the first term is minus 8, then the second term is minus 8 plus 2 minus 6. Minus 6 plus 2 minus 4. Likewise, you can find the remaining values. Right? Okay, then you can. We will stop the classroom here. Right? We will do the remaining in next Sunday, 31st Sunday. Right? අපි ක්ලාස් එක මෙතනින් නතර කරමු. අපි ඉතුරු ටික කරන්න ගියොත් එහෙම දැන් අපු නැති අයට පාඩු වෙනවනේ මේ ටික මොළම ටික ටිකක් සරලයිනේ. Right? So we will stop the class from here. Right? I will stop here. Join on next Sunday. 4 to we start from 4 to we will do 4 to 7, right? 3 hours on next 31st Sunday. Okay, then good night for all of you. And thank you for joining.